zone-based firewall. Now, zone-based firewall is a stateful firewall in iOS that is relatively modern, that is not the CBAC, which was quite frankly a terrible implementation of a stateful firewall. Now, for the CCI routing and switching test, as I said, we have to put things into perspective. This zone-based firewall configuration, if you have it in either troubleshooting or the configuration section, is going to be relatively straightforward. So I'm going to here just approach this from a very, very practical perspective. I'm going to build a simple network consisting of 3 devices. So this is going to be my R2, this is going to be my R5, and this is going to be R4. Here, this is going to be serial 0, 1, 0. This is going to be serial, actually this is 0 here, apologies. Serial 0, 1, 0 here, so I need to correct that. So this is serial 0, 1, 0. The network is 192.168.45.0/24. And here I have serial 0, 2, 0. And 192.168.25.0/24. All my routers will have loopback interface 192.168.0x/32, where x is 245, and I'm going to be running EIGRP 254 on them. Now, this is already pre-configured, so I already have these couple of things working in my network. So let me bring that up. So I'm going to connect to R2, R5, R4. And if I go to, let's say, R5, if I do show IP route EIGRP, I should be seeing, oops, I do have, maybe my EIGRP wasn't actually properly configured. Let me just do that very, very quickly. So I'm just going to say no router EIGRP 254, no auto summary network. Very, very simple configuration. I have auto summary enabled, and this is probably the fastest way to get rid of it. So let's see, show IP route EIGRP. So now I can see that on R5 I actually get 2 routes, one for loopback of R2 and the other one for the loopback of R4. So from R5 I can ping both of them, and from R2 I can ping the loopback of R4. So now what I would like to do with this setup here, I would like to implement a zone-based firewall on R5. So R5 here is going to be our zone-based firewall. And when we are dealing with stateful firewalls, we always have to think of the zones, and this is exactly what the zone-based stands for. So we are going to divide our network into 2 zones. You can call them whatever you like, but I'm going to call them, you know, using their traditional names. Let's say that this is going to be inside of our network, and this is going to be outside of our network. So I'm going to create 2 zones on R5, one that is going to be dealing with the inside and the other one that is going to be dealing with the outside. So, and these are the rules that I want to allow. So from inside to outside, so inside to outside, I want to allow ICMP echo from loopback 0 of R2, and I want to permit only appropriate echo replies. Which means that I don't want to just allow any echo replies. I want only responses to pings initiated from R2. That means that if R4 was to send unsolicited echo replies, they shouldn't get through. Only those replies that are part of the return traffic here. I also want to allow telnet from loopback 0 of R2 to loopback 0 of R4, and no other telnet. Also, allow only appropriate return traffic. Now, what I mean by allow appropriate return traffic is that if R4 was to initiate a wrong stream of packets coming from port 23 here, going to R2's loopback, that should not be allowed, because this is not the appropriate return traffic. Now, also what I want to do here is from outside to inside, I want to allow SSH from loopback 0 of R4 to loopback 0 of R2, and I want to have, let's say in this case, unrestricted. Actually, no, let's just do that. Just very, very simple stuff. Now, also what I want to do is that, let's add that bit into the mix. Inactive sessions should be terminated in 30 seconds. So if the session is inactive after 30 seconds, it should be cut. Also allow appropriate traffic to return. So this is the task, and let's see how we can build it. Now, every time you're dealing with a zone-based firewall, the fair warning is that you are going to have a lot of typing to do. Now, what do you need to do? What are the steps of configuring the zone-based firewall? Well, this is a very simple cheat sheet. So zone-based firewall steps. Number 1, create zones. Number 2, create policies. Oh, actually, define the traffic. That is interested. Create policies. Create zone pairs. And this is basically directional traffic. Apply policies to zone pairs. And finally, associate interfaces with zones. So this is the basic task list that we need. So let's start by creating our zones. So I'm going to go back to this page here, bring out my notepad. So the zones that I'm going to be dealing with, and let's start from left to right, is I'm going to have zone security, let's say inside zone security, outside So the next thing that I'm going to define is the classes of traffic. So I'm going to have class map type inspect, and let's say that I'm going to have echo, and here I'm going to have match protocol ICMP, but with match protocol ICMP I'm going to be matching all the ICMP traffic, but this is not what I want. I want only ICMP echo to be allowed. Now, I'm I'm fully aware that what I'm writing now is a broken firewall. The firewall should not be written like this to block all ICMP traffic. But this is just a matter of exercise here to see what kind of thing you might be asked to do. So what I need to do here is actually, I need something else. What I need here is I need an extended access list. And I'm just going to call it ICMP echo. And I'm going to say permit ICMP any echo. So this is going to further narrow down which traffic I'm interested in. And here in class map type inspect echo, this actually needs to be match all. Now, I have to admit that at this point, my syntax is giving up a little bit. So I'm becoming a little bit nervous that I might have some error. So these ones were okay. But for this one here, I'm always unsure what the actual order is, and I always have to figure it out. So it's going to be class map type inspect and then match all like this. So let me correct that. So there we go, match all echo. And I'm going to say match access group name ICMP echo. So now what I need to do here is I need to have ICMP traffic and I need to have ICMP echo. Now you might be thinking, why is he adding match protocol and the access group? Well, because if I don't add the match protocol, what's going to happen that all traffic is going to be sent to this class map for inspection to take a look is, does it match the access group? But if I narrow it down, the N bar feature on iOS is just going to identify the ICMP traffic and it's going to send to this class map only the ICMP traffic. So I don't have to pass all my traffic to this class map for processing. It's a little bit, tiny little bit more efficient doing it this way. So that would be one thing. Then I'm going to have another one, and which is going to be class map type inspect. Again, I need match all. And this is going to be telnet. And here I need match protocol telnet. And I need another access list. And in this case, it's going to be IP access list extended. Let's call it telnet. Actually, let me give these reminder that these are actually access lists. So here I'm going to have permit IP. And why am I doing IP? Because I don't really need to have permit TCP host and then the port numbers, because only telnet traffic will be sent here. So all I need to do here is to define that basically I need from loopback of R2, so permit host 192.168.0.2, host 192.168.0.4. So with this here, I'm going to narrow down which telnet traffic is going to actually match this class here. So I'm going to say match access group name telnet ACL. So this takes care for the traffic going from inside to outside. Now let's see what policies I might need in the other direction. I need to have class map type inspect. So there was a little typo here. Inspect match all again, and this is going to be SSH, and I'm going to have match protocol SSH and match access group name SSH ACL, and SSH ACL is pretty much going to be this one, just reversed. So at this moment here, we should have our classes of traffic defined. So now we have to write down the policies. So I'm going to have policy map type inspect, let's say inside to outside policy. And here I'm going to have class echo, and I'm going to say inspect. Now, what does inspect do here? It basically takes care of this second requirement, only appropriate echo replies. That means that I'm automatically going to allow the traffic that is going to be the result of this session. So when I send the echo, my N bar knows, the zone-based firewall knows that the return to this traffic should be either the ICMP unreachable or ICMP echo reply. So if I'm inspecting the outgoing echoes, I know to allow echo replies in return. And also I'm going to do the same thing for telnet. So class telnet, here I'm going to say inspect. Now I'm going to have policy outside to inside, so I'm just going to copy paste this. So outside to inside policy, and in this case I just need to have the SSH. For now I'm ignoring this requirement for inactive SSH sessions. I just want to get the basics up and running. Then after this I need to define policy pair. So I'm going to have zone pair, and again unfortunately this is where my syntax gives up, zone-based security. Okay, so zone pair security, I'm going to have, let's say, inside, outside, I have to give it name, source, so I have to specify what is the source zone, and destination, outside, and here I have to apply service policy, type, okay, again, I have to admit my syntax gives up, service policy, type inspect, or is it type security? Type inspect, and then I am applying inside to outside dash policy. And oops, I think I may have made a mistake here. Let me just see. Yep, that's what I was missing, but luckily I saved that in my copy-paste buffer. So what I need next is outside to inside, source outside, destination inside, and here out and in. Finally, I'm going to go to my interfaces, so interface serial 020, and I'm going to say that this this is a zone member security inside, and that this interface here is zone member outside. So this is hopefully the all configuration that I have to do. So let's just exit here and start from scratch. And when I'm pasting this in, I'm just going to do it one thing at a time to see if I have any errors somewhere. So far so good. Policies. And let's say zone pairs. That worked. And interfaces into zones. That works. So now let's take a look if our policy actually works. So from R2, I'm going to ping R4, and well, this should have not worked. So why did this work? Let's see. Permit ICMP any echo. So that was their match protocol ICMP. What was it any? Oh, from loopback of R2. I am sorry. So this here was wrong. So what I'm going to do is just going to fix that, and I'm going to say permit ICMP host 192.168.0.2. Just didn't implement my access list properly. So let's go fix that. So what I'm going to be doing is I want to remove this line and replace it with this other line. So now, if I try to ping R4, this should be failing now because I am not pinging from the loopback interface. Okay, but if I ping from the loopback interface of R4, I should be getting the responses back because now the return traffic is actually allowed. From R4, if I try to ping, this should not be working. Okay, so this was the test for the first policy. Let's say telnet from R2 to R4. So I'm going to say telnet 192.168.0.4. This should be failing, and this should be failing because I need to specify source interface loopback 0, and when I do that, I can see that my telnet actually worked. Now, there was no requirement to actually make the telnet work, but I can do that if I want to do. So let's say here line VTY04, let's say password IP expert, just to make sure that I can actually telnet there and that my telnet is operational. Now, let's see the other way around. So from outside to inside, I have to allow SSH from R4 to R2. Same way here, let's enable SSH. So I'm just going to say crypto key generate RSA label R2 module 1024. Let's do that. So SSH has been enabled. Let's do the same thing on R4. Just going to change the label to be R4. And let's create a username. Let's say IP expert, password IP expert, line VTY04, login local, transport input SSH. So now from R4, if I try to SSH -L IP expert 192.168.0.2, this should be hanging. This shouldn't work. It shouldn't work because I need to initiate this SSH session from the loopback interface. So how do I do that? First, how do I interrupt this? Now, unlike telnet, where you can actually specify the source interface, the SSH client on the SSH client on Cisco iOS does not allow you to do that in the command line. But what you can do in the configuration mode, you can say IP SSH source interface loopback 0. So now when I do SSH, I should be going out of the loopback interface, and I can see that this is actually now letting me in. And if I try to log in as IP expert, I am in. But let's take a look at that other part of the configuration where we are told that inactive SSH sessions should be terminated in 30 seconds. So let's go to R5 here, and to do that, we are going to configure something that is called the parameter map. So this is going to be parameter map type inspect, and I'm just going to call it SSH timeout. And here I'm going to say TCP idle time 30. So now, if I do show run section parameter map, this is the parameter map that I actually have configured. So let me add it back to that large notepad file that I have here. So I'm just going to add it here at this moment. So here where I have class SSH in my outside to inside policy, this is where I'm going to go now, and I'm going to say inspect and take a look. Now I have a parameter map that I can specify. So I'm going to say SSH timeout. So this is where I'm actually going to apply this parameter map. So now what's going to be happening, that those sessions that are inactive for 30 seconds, so let's see it. So here I'm logging in as IP expert. So now I should be waiting for 30 seconds to see this parameter map actually kick in. Now, 30 seconds is a long time. So let's make that parameter map a little bit more efficient. So I'm going to say parameter map idle time, let's say 10 seconds. So now, let's say exit here. I'm going to SSH here, going to say IP expert, and let's wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, about now I should be disconnected, and there we go, because I was counting a little bit too fast. So we can see that this session was idle for 10 seconds, and R5 actually just destroyed that session after that idle time. But anyways, this wasn't what we were asked to do, so let's just go back and set it back to 30 seconds, because this is what the task asked me to do. Now, you can see that this was rather long typing exercise. You had a lot to type, but the point is that zone-based firewall in the lab is not actually going to be much more complicated than this. This would be the extent of it. These are the things, or these are the kind of tasks that you might be expected to do. So expect to write some access list, expect to combine access lists with the nbar in your policy, in your classes, and you need to apply the policies and then know how to use. And basic parameters map for basic protocols. One of the questions here that I had now is, what about allowing the protocols for zone self? Well, zone self is a zone that is created on the zone-based firewalls by default. And all interfaces, all traffic going to the router itself is always member of zone self. So now, if we take a look at this network diagram, from R2 here, I know that I cannot ping this interface here, because this is what the task is asking me. But can I actually ping this interface here on R5? So if I go to R2 and I say ping 192.168.45.5, sorry, 45.4 won't work, but 45.5, take a look at this. This works. Even though this interface here is technically speaking part of the outside zone, the traffic going to the router itself is actually part. So this interface, and the loopback interface, they all make up zone self. So from R2, I can actually ping even this. I can actually telnet to 192.168.45.5, even though technically speaking this interface is out. Now, when you are using zone-based firewall, you don't actually have to worry about routing protocols. Now, between R2 and R5, take a look, show IP EIGRP interfaces. I do have neighbors there, neighbors exist, show IP route EIGRP. So my routing protocol was actually intact, because routing protocol was communicating in between R2 and zone self on R5, and R4 and zone self on R5. So when you're using zone-based firewall, you don't actually have to worry about these things, which is something that you would have to worry about if you were using just plain access list or if you were using CBAC. Let's now add to our firewall another rule. Let's allow traceroute from this interface to this interface to go through R5. So this is going to be the traceroute here. And I want this to be the source interface, this to be the destination interface, but I do not want to inspect it. So I want to just use the path. Now, what I need to do is allow, and Cisco routers don't use ICMP for traceroute, they use UDP. So I need to allow some UDP traffic this way, and I will need to allow ICMP unreachables back in the direction from zone outside to zone inside. So let's take a look at that. So what I need now is this. And you know, one thing that about the traceroute, you know, which UDP port numbers is it using? Well, I'm not entirely sure, but how would I even find out which port numbers it is using? Well, there is a very simple way to do that. So on R2, I'm just going to say access list 100 permit UDP any. So I know it is going to be actually UDP any. Let me not do that. So I'm just going to say access list 100 permit UDP any, actually any host 192.168.45.4. So I don't know which port numbers are used by UDP. Now, I should know as the CCI instructor, but I can't possibly remember that. So by traceroute, sorry. So I'm going to say debug IP packets 100, and I'm going to say traceroute 192.168.45.5. So what I want to see here, 45.4, what I want to see here is sending full packet. It is not giving me the port numbers. Okay. Debug IP packet detail. Okay. So let's see this. Am I going to see that? Yep, there it is. 33436, 437. So I'm going to have packets going. So UDP ports starting from 33434. Okay. So let's bring in this. So this is going to be the start. And then this much I do know, as the TTL is actually increasing, the port numbers are going to be increasing as well. So 33445 is what I have here. So what I need is, I know the trace route goes for 30 hops. So basically, these are the port numbers that I will be using. Okay. So handy calculator, thank you very much. Let's interrupt this, undebug all. No access list 100. Thank you very much, access list. So what I'm going to be doing here is I need to take a look at adding this policy. So I'm going to go to R5 and I need to add IP access list. Let's say trace route out access list, and this is going to be permit UDP host 192.168.25.2 host 192.168.45 for, let's say, greater than this and lower and equal than this. I believe this is the syntax. Let me just quickly check this. IP access list extended, always forget that one. And then this goes in. Oops, let's see. Can I use, okay, lower than, okay, so it needs to be lower than, not lower equal. Oh, why not? Okay, maybe I need to have lower and then greater than in the other direction. So let's try that. Or maybe I cannot use them on the same line. So let's see. Okay, I cannot use them on the same line. So let's just use greater than then. And lower than here, 3. Actually, this is just fine then. Or maybe, oh no, sorry. Oh, silly me, there is a range here. Okay. So let's do that. So range 33434 and 33464. So I can do that here. So do show access list. So let's see, I do have this. Then what I need to do is I need to define the return traffic. So this is going in, and this would be permit ICMP host 45 4 to 25 5 unreachable. So that will be that. So now I'm going to have class map type inspect, it is going to be traceroute going outbound, and here I'm going to have match. Well, do I have match protocol traceroute? I doubt it. No, of course we don't. So we are just going to use match access group name traceroute out ACL. And then we are going to have traceroute in. Here we can say match all, and we're going to have match protocol ICMP, send only that in, and traceroute in ACL, so we can use this. Then we are going to look at our policies. So I'm going to say show run section policy map. So what I'm going to do for inside, outside, I'm going to add class type inspect. What was it? Traceroute out. And I'm going to pass the traffic out. So before I actually make this work, so right now when I do the traceroute, this is going to be failing. Let's go to R4 here, and let's say access list 100 permit UDP any range, and let's use the same range of ports to see if we are actually getting these packets. If these packets are arriving. So debug IP packet 100. So are these packets arriving? So now we can see that on R4, the packets are actually arriving from R2. So our policy from inside to out actually worked, because here they are, the packets are arriving. Obviously, we are not getting any responses back because the policy for return traffic is not in place, because I used pass. Now, when you use pass, you are not automatically allowing the return traffic. We are just saying, okay, this traffic can go out, and this is exactly the situation we have. So now what we need to do is we need to go back to our policy and actually apply this policy for return traffic, that unreachables from this host are actually going to be allowed back in. So I'm going to go now into this policy map, outside in, and I'm going to say class traceroute in, and I'm going to say pass the traffic. So now the next packet, okay, maybe I just need to exit here. Let's see, traceroute. No, doesn't work. Let's see why not. So are we actually sending the packet as return traffic? So to do that, I'm going to say no access list 100. And I'm going to say access list 100 permit any. Oh, no, not going to do that. Permit ICMP any. And let's do debug IP packet 100 detail. So I want to see if I'm actually generating any traffic back. Do undebug all. So let's see. So we are getting the packet from 45.4 destination 25.2. What do I actually have here? 45.4 destination 25.5. Ah, that's the problem. So I have a typo in the access list. Excellent. So do show run section IP access list. So there is a typo here, so this is wrong. So no 10, and this now needs to change to 2. Now the traceroute actually works, and we used pass instead of inspect. But you see, it's a little bit more work. You have to understand the protocol, and if you can't remember the things that I honestly did, so I wasn't playing around. I really couldn't remember the port numbers in use for the trace route, which is okay, but I've shown you how you can actually figure them out, right? I used only the tools that were available for me in the lab, so I wasn't going to the documentation, didn't go to the Google, I just used the debug. Okay, which ports are in use about the trace route? I know it's UDP, but I don't know which ports. So figured that out, went in there, configured the policy, made sure that it works in one direction, and then just made it work in the other direction. And actually, because of the typo that I had in the access list here, where I used 5 instead of 2, I was actually able to confirm that my policy wasn't going to allow other unreachable packets from coming in, which even more narrows it down as a solution. Now, obviously, all unreachables from this host to this host will now be sent, not only those sent in response to this trace route, but it is what it is. This is what the path actually means. It simply means allow this traffic if it matches these parameters.